Hey guys, welcome to video 1, polar coordinates. Polar coordinates are another way of expressing a point in a plane. Traditionally, see we have this point P here on this graph, we would represent that with an XY coordinate. That's what you've learned up to now. And what that meant was that you were going out some X amount of units on the X-axis, which is your horizontal axis, and then you were going up some amount of units. So that line's way too thin. Let's make that a little thicker. And you were going up some y amount of units from the x-axis to get to that point. So you went out x and then up or down y. In this case, we're in quadrant 1, so we're going up y. So like the point, 5 comma 2. You went to the right 5 and then up 2, right? And when we were doing trigonometry in Algebra 2, we learned that we could kind of turn this into a triangle, and what we started to do was realize that we could think of this in terms of an angle in a right triangle, and this would be angle theta, and measure the angle off of this x-axis, the initial side of an angle. Our angles, our positive angles, we know we open counterclockwise, like in this case. We always start at the x-axis and we open up counterclockwise. So let's say this is an angle of 40 degrees, something like that. And we would do trigonometry with that. And also with this right triangle, we realize that we have a hypotenuse here, and we could call that r. I mean, the reason why we're calling it r is because we could also think of this as a big circle centered at the origin, and r would be the radius of that circle. But really, right now, you can think of it as the hypotenuse of this little right triangle we just created that's extending to this point P here. So again, to get to point P, up until now you had what were called rectangular coordinates. There was x comma y. You go over x and up y. Well, now we're realizing there's another way to actually get to point P instead of going by a step like over and up, where we could, starting at the origin and facing out on the x-axis, just like this is facing out here, you could turn counterclockwise theta amount of degrees, say 40 degrees, and then walk straight out r units. And that's another way to get to point P. And so point P could be thought of as r comma theta. And that's a polar coordinate. XY is a rectangular coordinate. R comma theta is a polar coordinate. And so in this video, we're going to learn how to plot polar coordinates. And this is really what we're working with in the rest of the chapter is coordinates like this. And we're going to be converting back and forth and stuff like that. But let's take a look at the polar grid. And so this is what a grid looks like for a polar graph. And it's very different than an XY axis, but it does have some similarities. Let me just point out a couple of things that it has that are similar. It still kind of has, in a sense, this XY axis boundary. And we do very much use this positive, horizontal as where we start everything, where, we're not going to call it the x-axis, but it's still the initial side of where everything begins. And you still have quadrants, right? I mean, this section over here, this would be thought of as quadrant 1, and this would be quadrant 2, and this is quadrant 3, and this is quadrant 4. And so there are still quadrants, and so there is a lot of crossover. In fact, you could overlap your normal looking graph right on top of this, and you would see it kind of overlap kind of nicely. But anyways, the way to work on a polar grid is you see that there's these circles extending out from the origin. Like there's one here, and then there's another one here. And sorry, it's pretty sloppy, but you can see the circles. They represent the units from the origin. So this would be a unit of 1. This is a unit of 2. This is a unit of 3. This is a unit of 4. This is a unit of 5. So those are units out from our starting center origin point. And so all these circles represent how far out you are from the origin. And so this has a maximum length of 5 units out from the origin. And then you see these lines extending out. And what each of these lines represent is a different degree measure from your initial side. And so if we start, we start right here, and you would open up, this would be the 30-degree line. That every point on here is 30 degrees from our initial starting side. And so something like this point right here, would have a coordinate of 3, 30 degrees. Because it's 3 units out from the origin. It's 3 arc lengths, right? That's 1, 2, 3 arc lengths out from the origin. And this is a 30-degree angle above the axis. This was a 45-degree angle, and this is a 60-degree angle. And those are your special angles that we focus so much on in trigonometry, 30, 45, 60. This is a 90-degree angle. And then the rest of these are references of those. Like this, and this. These are your 30-degree reference angles. And so that would be 150, 210, and 330. And then these are your 45-degree reference angles. They're each 45 degrees away from the axis. 135 is 45 short of 180. 225 is 45 over 180. And 315 is 45 short of 360. And my 30 from 330 got erased. And then lastly, this would be 120, your reference of 60 in quadrant 2, 60 degrees away from 180. We might as well label 180 while we're there. And then this would be 240, 60 past 180. This is our 270. We know that goes down there. And 300 is a reference of 60 degrees away from the 360 line. And so that's your polar grid. It's all your special angles and their references in the quadrantals, labeling, and then counting how many circular units out from the origin you are. So let's practice plotting a couple of points. So plotting the polar coordinates. First we're going to just focus on r greater than 0. That's the first number. So when this number is positive, it's pretty simple. 3, 60 degrees means, and now there's 2 ways you could really look at this. Typically when we graph like an xy coordinate, we always do x first, y second. I guess we don't really have to. I mean, we could technically go up first and then over, as opposed to over and then up gets to the same place. But we don't want to confuse ourselves, so we always, train ourselves to think x, y, go to the right, side to side first, then up and down second. But polar coordinates, we can do this one of 2 ways. I could think of the 3 units first, and then think of, all right, 3 units out is here. And then I could go 60 degrees up. 60 degrees is right here. This is the 60-degree line. So this point right here is 3, 60 degrees. But I think some people will actually do that kind of backwards. Well, let me just erase that all for a minute. Where what they'll do is they'll think, all right, here's the 60-degree line, and go 3 out. And I don't know if maybe that's easier in this to kind of work backwards a little bit. You're going to have to figure out what works best for you. Where do you want to think about the distance out and then the angle, or do you want to go to the angle and then go to the distance out on that line? It's up to you. And so either way, this is the point 3, 60 degrees. 4, 2, 10. So now, after you do this a couple of times, you're going to start to memorize what all of these angles are. You don't need to label it every time, but it's helpful to narrow it down to the quadrant at least. 210 is in quadrant 3. It's between 180 and 270. And it is 30 degrees past the 180 line. And so that's how I can remember that this line right here is the 210 line. And 4 out from the origin, 1, 2, 3, 4, would be right here. And so that's the point 4, 210. And again, I could have, instead I could have started here, went out 4, and then rotated 210 degrees, and I would get there. But I think actually finding the angle line first is easier, in my opinion, and then just going out that many. Like 2, 270. 270 is here. It's a quadrantal angle, and I'm just going to go 2 out from the origin, so it's right there. That's my 2, 270. And I'll do one more. 5, 135. 135 is in quadrant 2. It is 45 short of 180, and a distance of 5 out from that is right here. So that's the 0.5 comma 135. So those are plotting polar coordinates where r is greater than 0. Let's look at just a couple of examples where when r is less than 0, because it's a little bit different. So these are when your r values are negative. And what you want to do for this, let's get our first example here, negative 3 comma 45 degrees, is you kind of want to first pretend it's positive 3 comma 45 and go to that location first. And so here's my 45 degree line, and if it were positive 345, I would be here. But I'm not. When r is negative, you actually end up in the opposite quadrant. So what that means is I'm going to end up, if I kind of trace this line back, I end up here. This is the point negative 345. And so when your r value is negative, you end up in the opposite quadrant of your angle. For another example, negative 2 comma 150. Now the 150 line is right here. 150 is 30 away from 180. So that's my 150 line, and 2 out would be here. But because I'm negative 2, I'm going to end up over here. And this is negative 2 comma 150. And so it's a little backwards. You actually need to kind of go backwards a little bit in a sense that you need to kind of shoot across your circle. But it's helpful to use these lines to kind of trace it through and end up there. And so that's how you graph a polar coordinate where r is less than 0. Let's just do a couple more real quick. Negative 4, 180. Well, this would be positive 4, 180. So that means shoot across. This is negative 4, 180. And finally, negative 5. Let me mark that, make that marker a little bit thinner. Negative 5, 300. The 300 line is here, 60 away from 360. This is the positive 5, 300. Follow it across. Here's your negative 5, 300. All right, and that's plotting polar coordinates. See ya.